Hey guys. This is Space Train. Your daily express till the edge of the space. And today we will talk about, what is a black matter? Grab your tickets and let's go. Don't forget to subscribe to get unlimited pass on our expedition. Galaxies in our universe seem to be achieving an impossible feat. They are rotating with such speed that the gravity generated by their observable matter could not possibly hold them together. They should have torn themselves apart long ago. The same is true of galaxies and clusters, which leads scientists to believe that something we cannot see is at work. They think something we have yet to detect directly is giving these galaxies extra mass, generating the extra gravity they need to stay intact. This strange and unknown matter was called dark matter since it is not visible. By fitting a theoretical model of the composition of the universe to the combined set of cosmological observations, scientists have come up with a composition that the universe contains 68% dark energy, 27% dark matter, 5% normal matter. We talk about dark energy in our last video. You can check link down below. First, we have to answer question what's the difference between dark energy and dark matter. Although the names seem to imply that they are similar, dark energy and dark matter are not directly related. Dark energy is the force responsible for the acceleration of the expansion of the universe at a never-increasing rate since the Big Bang. Dark matter, on the other hand, consists of the unseen particles that bind our universe, and even our own bodies, together. Although astronomers can't see dark matter through a telescope, they can locate dark matter by its gravitational effects on its surroundings and the detectable X-rays it emits, as explained by Craig Freudenreich. Where dark matter is the force that keeps the universe together and explains how the cohesion of the stars, galaxies and more is even possible, dark energy pushes it apart. Let's go back to our basic question. What is dark matter? Unlike normal matter, dark matter does not interact with the electromagnetic force. This means it does not absorb, reflect or emit light, making it extremely hard to spot. In fact, researchers have been able to infer the existence of dark matter only from the gravitational effect it seems to have on visible matter. Dark matter seems to outweigh visible matter roughly 6-to-1, making up about 27% of the universe. Here's a sobering fact. The matter we know and that makes up all stars and galaxies only accounts for 5% of the content of the universe. But what is dark matter? One idea is that it could contain supersymmetric particles, hypothesized particles that are partners to those already known in the Standard Model. Experiments at the Large Hadron Collider, LHC, may provide more direct clues about dark matter. Many theories say the dark matter particles would be light enough to be produced at the LHC. If they were created at the LHC, they would escape through the detectors unnoticed. However, they would carry away energy and momentum, so physicists could infer their existence from the amount of energy and momentum missing after a collision. Dark matter candidates arise frequently in theories that suggest physics beyond the Standard Model, such as supersymmetry and extra dimensions. One theory suggests the existence of a hidden valley, a parallel world made of dark matter having very little in common with matter we know. If one of these theories proved to be true, it could help scientists gain a better understanding of the composition of our universe and in particular, how galaxies hold together. Studies of other galaxies in the 1950s first indicated that the universe contained more matter than seen by the naked eye. Support for dark matter has grown, and although no solid direct evidence of dark matter has been detected, there have been strong possibilities in recent years. Motions of the stars tell you how much matter there is, Peter Van Dokkum, a researcher at Yale University, said in a statement. They don't care what form the matter is, they just tell you that it's there. Van Dokkum led a team that identified the galaxy Dragonfly 44, which is composed almost entirely of dark matter. The familiar material of the universe, known as baryonic matter, is composed of protons, neutrons and electrons. Dark matter may be made of baryonic or non-baryonic matter. To hold the elements of the universe together, dark matter must make up approximately 80% of its matter. The missing matter could simply be more challenging to detect, made up of regular, baryonic matter. Potential candidates include dim brown dwarfs, white dwarfs and neutrino stars. Supermassive black holes could also be part of the difference. But these hard-to-spot objects would have to play a more dominant role than scientists have observed to make up the missing mass, while other elements suggest that dark matter is more exotic. Most scientists think that dark matter is composed of non-baryonic matter. The lead candidate, WIMPs, weakly interacting massive particles, have 10 to 100 times the mass of a proton, but their weak interactions with normal matter make them difficult to detect. Neutralinos, massive hypothetical particles heavier and slower than neutrinos, are the foremost candidate, though they have yet to be spotted. Sterile neutrinos are another candidate. Neutrinos are particles that don't make up regular matter. A river of neutrinos streams from the sun, but because they rarely interact with normal matter, they pass through the Earth and its inhabitants. There are 3 known types of neutrinos. A fourth, the sterile neutrino, is proposed as a dark matter candidate. The sterile neutrino would only interact with regular matter through gravity. One of the outstanding questions is whether there is a pattern to the fractions that go into each neutrino species. Thijs de Jong, an associate professor of physics and astronomy at Michigan State University and a collaborator on the IceCube experiment, said. The smaller neutral axon and the uncharged photinos are also potential placeholders for dark matter. According to a statement by the Gran Sasso National Laboratory in Italy, LNGS, several astronomical measurements have corroborated the existence of dark matter, leading to a worldwide effort to observe directly dark matter particle interactions with ordinary matter in extremely sensitive detectors, which would confirm its existence and shed light on its properties. However, these interactions are so feeble that they have escaped direct detection up to this point, forcing scientists to build detectors that are more and more sensitive. A third possibility exists, that the laws of gravity that have thus far successfully described the motion of objects within the solar system require revision. Maybe in future, we will come out with the better theories of gravity. Don't forget to comment your what do you think, which of this hypothesis are more close to reality. For a theorist, an observer or an experimentalist, dark matter is a promising target for research. We know it exists, but we do not yet know what it is at a fundamental level. The reason we do not know might be obvious by now, it is just not interacting enough to tell us, at least so far. As humans, we can only do so much if ordinary matter is essentially oblivious to anything but dark matter's very existence. But if dark matter has some more interesting properties, researchers are poised to find them. There are lots of questions left, so don't space out, and leave some space in your brain for answers. I hope you enjoyed this video. If you want to see more, subscribe and click the bell button, to get notifications on our latest videos. If you are still here, grab your knowledge and get out of my train.